In this lesson, we're going to talk about squaring a number and cubing a number. So let's first take a look at squaring a number and what that means. The square of a number is the number to the power of 2. So it's something like x squared or 3 squared, and it would look something like this: x squared or a number squared. And we get this squared because if we look over here at the square that we have this side length that is 4. And then we also have another side length that is 4. And we know that the formula for the area of a square, which is what we have here, is A equals the side squared. So really what we're doing is we're taking that side length. In our case, our side length is 4. And the one over here is 4 as well. And we're saying A equals 4 squared. And when we do that, we get A equals 16. And that would be units squared. And what is the 16? Well, it's actually all of these little squares. So that's essentially what you're doing whenever you square a number. You're taking the base number and you're multiplying it by itself. Let's look at some of the perfect squares. Perfect squares are like the one that we see above, meaning they have 2 side lengths that are equal, meaning one side length is 4 and the other is 4. If we had a square that had a side length of 1, we would say 1 times 1 is 1. If we had a square that had a side length of 2, it would be 2 times 2 is 4. And we can continue that pattern all the way up to 10. So 3 squared is 9. 4 squared we see above is 16. 5 squared is 25. You're probably very familiar with these numbers. 6 squared is going to be 36. 7 squared is going to be 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. So those perfect squares are definitely ones that you want to commit to your memory if you haven't done so already. Now let's look at cubing a number. The cube of a number is the number to the 3rd power. Now it's if we were to write it, it would be something like x cubed or 3 cubed. And where we get the idea of cubing is now we're actually looking at 3 dimensions. So we have this, we'll call it a length, we'll call this a width, and we'll call this a height. So instead of multiplying 2 dimensions together, like we did previously, we're actually going to multiply 3 dimensions together. And that's where we're getting the 3. So when you see in this case, we actually have a side length of 4. That was a length and then a width of 4 and then a height of 4. So if we were to go ahead and multiply those and say 4 times 4 times 4, that's going to give us 64. So this whole area within this cube, even the cubes that you can't see that are behind the ones that I just shaded, it is a total of 64 cubes. So that's essentially what cubing is actually doing. There are some perfect cubes, just like the one that we see above here. And these might not be as common as the perfect squares, but definitely something to try to commit to your memory. So 1 cube is just going to be 1 times 1 times 1, which is nice and easy. That's just going to give us 1. And 2 cubed is pretty common too. 2 times 2 times 2 is going to give us an 8. 3 cubed, that's going to give us 27. 4 cubed is the one we did right above. That's going to be 64. I find that it starts getting a little tricky here at 5. So 5 cubed is going to be 5 times 5 times 5, which is 125. 6 cubed is going to be 6 times 6 times 6, which is going to be 216. 7 cubed is going to be 343. 8 cubed is going to be 512. 9 cubed is going to be 729. And my favorite one, 10 cubed, is going to be 1,000. So those are the most, the perfect squares and cubes that we're probably going to be using a lot this year. All right, moving on. These are some tips for you. And when I say very careful, I really mean very careful. These are very tricky to work with when we're working with exponents with bases. So let's look at these 4 examples and let's see the difference between all of these. 3 squared, well, we talked about that already. That's basically saying 3 times 3, right? And that's easy, that's 9. Okay, but look at the one below it. Notice I have parentheses. Now, what those parentheses are saying is that everything inside the parentheses is is my base number, and that's the number that I'm going to multiply by itself twice. So you'll notice that I have negative 3 times negative 3, and that's going to give me 9 as well. Interesting that both of them are positive 9. Now, this is where it gets tricky. In the next one, you notice that there are no parentheses. Well, no parentheses means that the base number is actually the number by itself. If you remember from the last lesson with absolute value, we had that imaginary negative 1 out front. Well, technically, there's an imaginary negative 1 outside the 3. Another way that we could actually write this statement is like this. Negative with a 3 inside squared. And we kind of like seeing that better because we can see here that this is actually saying 3 times 3 and then getting an answer of 9, right? But then this negative outside, we have to multiply it by a negative 1 to give us a negative 9. So be really careful with that negative outside when you don't have parentheses. There definitely is a difference between those two. Okay, and then the last one. Now we've got negatives all over the place, but just stick to your order of operations here. Remember, exponents are going to come before multiplication. So yes, I do have this negative 1 outside, but I have to square my negative 3 first before I multiply by negative 1. So let me break this down for us. Negative 3 is in parentheses, so really what I have is negative 3 times negative 3, and that's going to equal 9. But I have that negative 1 outside that I have to multiply my my answer by. So I'm actually going to get an answer of negative 9. So those are just some very careful tools to think about. And if you use your graphing calculator and you type it in just like we did these 4, you will get those answers that we got. 9, 9, negative 9, and negative 9. So let me show you where this is valuable. It says here, evaluate for each replacement set. Remember we talked about a replacement set in the last lesson. Replacement sets are basically numbers that you substitute in for variables. So in our case, in letter A here, we had x equals 4. Let's go ahead and substitute that into x. So you'll notice that my x is equal 4. That's my base. So really what I have is this, 4 squared. Or I could even say 4 squared. They mean the same thing, which would give us an answer of 16. But the next one's tricky, isn't it? X is negative 5. X is negative 5. Well, if I did this and I squared it, isn't that different than negative 5 in parentheses? So if you're given the replacement value of negative 5, you want to make sure that you put that negative 5 in parentheses because that is going to yield a positive answer. By the way, anytime you ever square something, your answer is always going to be positive. Okay, let's do another one. Now, again, very tricky part. Notice I have a negative outside of my x, right? Well, when I look at my a here, x equals 4. Always remember, the x is 4. So really what I have parentheses around my x. So I'm going to write negative parentheses 4 squared. And we know that that's going to be 4 squared is 16 multiplied by negative 1 gives me negative 16. My next one's going to be negative. I'm going to put my negative 5 in my parentheses and I'm going to square it. My exponents first, negative 5 squared is going to be 25. But then I'm going to multiply it by that negative 1 outside to give me negative 25. So very, very careful with these little pieces here. Okay, so let's talk more about the square root and the cube root. So taking the square root of a number is the inverse of squaring a number. So if you're squaring a number, if you want to do the opposite of that, you actually take the square root of it. And this is what a square root looks like. Same thing with a cube root. If you take the cube of a number, like x cubed, if you want to take the opposite of that number or the inverse, you take the cube of that number. Or the cube root of that number. And it looks like this below. The only difference is the little 3 here. And sometimes you can take the 4th root and the 5th root and the 6th root. And the only thing that will change is this number right here. But this year we're really just going to focus on the square root and the cube root. Okay, so some different symbols that you might see here. So the square root of 64 we know is 8. Now, notice the difference in this second one. Notice I have a plus and a minus. What that means is that it wants you to yield the plus and the negative 8. When we talk about quadratics later on this year, we're going to talk about those what that plus and minus 8 means. But I'll give you a little rundown of it. Basically, what I could say is, can I say that 8 times 8 is 64? And can I say negative 8 times negative 8 equals 64? So really, the positive and the negative number 8 will give me a square root of, is the square root of 64. Because I can take those numbers and multiply them to give me that number underneath the root, which is 64. Okay, moving on. The next one, notice that I have a minus 64. That just means that I want the negative of the root underneath. And then the last one, the square root of negative 64. Well, feel free to try this in your calculator, but I'm just going to tell you right now, this is not possible because I can't have two numbers that are exactly the same and multiplying them together to give me negative 64. Give it a try. There are no numbers. So what this means basically is we like to write no real roots exist here. Now, later on, when you get to Algebra 2, you're going to talk about imaginary numbers, and that will come into play in these types of problems. One more thing about the square root that I'd like to talk about is, let's go back up here to the square root of 64. When you have an answer of a positive number, and you only have the positive number, this is called the principal root. Yeah, the principal root is just going to be the positive root. So right now, we're just going to talk about the principal root, but later again, when we talked about quadratics, we're going to talk about the positive and the negative root. Okay, let's talk about the cube root now. All right, the cube root is a little bit different. So before, when we were talking about the square root, we were looking for a number times a number is going to give me that number underneath, that radical symbol. But now I'm looking for a number times a number times a number, all being the same number. So everywhere you see a star is going to be the same number. And that whole big piece is going to equal what's underneath the radical. So just like our cube up in the last slide, we know that 4 times 4 times 4 is going to give us what's underneath here, 64. Therefore, the cube root of 64 is going to be 4. And then in the next one, it looks a little bit different. It has a negative out front. And it doesn't work exactly like the square root. It's going to work a little bit differently. Again, I need those three numbers that are going to give me positive 64. But it's not as easy now because now I have a negative outside. So in this case, I'm still going to look at it and say, okay, square root of 64, that's going to be 4. So 4 times 4 times 4. Okay, so I have 4 as my answer, but remember I have that negative outside, and that's going to make it a negative 4. Okay. Okay, this next one, now, unlike the square root, we have this negative inside the radical, but But this time it's a little different because, again, we're multiplying three numbers by themselves. So we have to kind of think about it. What kind of number is going to give me a negative number? Well, if I have a negative number, a negative times a negative is a positive, and then a positive times a negative is a negative. So I know that that number is going to be negative. And we've been working with 4, so let's go ahead and try negative 4. When we multiply those numbers, that is going to give me that negative 64. Therefore, my cube root of negative 64 is going to be negative 4. And then my last one, the inside looks identical to the one before. So we know that number that we're multiplying is going to be negative 4. So we know that the cube root is going to be negative 4. But again, we have that negative 1 outside that we need to multiply it by. So if I multiply it by that negative 1, then my answer is going to be 4. So you have to be very, very careful with all the signs and operations and all that you have to work with. All right, let's try a couple together and see if we can evaluate some of these expressions. So it says evaluate when x equals 16 and y equals 3. So those are my replacement values. So I'm going to go ahead and replace them into my expression. The square root of 16 plus 3. I can evaluate my square root of 16, which is 4, because 4 times 4 is 16. And then I can simplify it all the way down to get 7. Number 2, evaluate when x equals 125 and y equals 6. All right, so the cube root of x, which is 125, plus 6. So the cube root of 125 is 5, and I'm going to add 6 to give me 11. Number 3, evaluate when x equals 25 and y equals 4. I'm going to go ahead and substitute that in. 2 times the square root of 25. 25 minus 4. Okay, let's go ahead and simplify this. Remember to do your order of operations here. Let's go ahead and simplify our square root here. So I have 2 times 5 minus 4. I'm going to do my multiplication first to give me 6. And then my last one, evaluate when x equals negative 8 and y equals 7. So I have 4 times the cube root of negative 8 plus 7. Okay, 4 times, now the cube root of negative 8, remember it's a negative number inside, so you probably are looking for a negative number. So I'm thinking negative 2 times negative 2 is 4, and then 4 times negative 2 is negative 8. So we're going to multiply it by negative 2 plus 7. All right, multiplication, negative 8 plus 7. Using our integer skills, negative 8 plus 7 is going to be negative 1. Okay, I want to show you this on the graphing calculator here. Exponents are used to represent repeated multiplication. We kind of talked about that earlier, like 2 times 2 times 2 times 2 times 2 is 2 to the 5th. And this is a really just important fact. Anytime you raise a negative number to a power, you must use parentheses. We talked about that earlier. But basically I wanted to show you how to do this here on the calculator. If you're going to square something, if you're going to square a number, you're going to use this button right here, x squared. So if you go ahead and type in the number 5 and then type in that button, you'll notice that it's going to square that number that you have. If you want to put the number in parentheses, here are where your parentheses are. And what you're going to have to do is parentheses, pop your 5 in there, close your parentheses, and put your little exponent outside. Another way to do it is this little caret here. Yeah, a little caret. Not as common, but feel free to use it. You can do something like 5, and then if you click that caret, that's basically saying, okay, I'm going to raise it to the what power? Second power. We really don't use that button much when working with, when we're raising things to the second power. We use it more for when we cube a number or if we raise it to the 4th power. So feel free and go ahead and try -2 to the caret 6th power and see what you get from there. Okay, these are just a couple for you to try just on your graphing calculator. Just try using the square root and the cube root in your calculator. So let's go over those directions. If we are going to square root a number like 256, what we're going to have to do is we're going to use the buttons second, which is the blue button, and then we're going to use that x squared that we just used. So go ahead and type in second x squared and then type in 256. And you'll see that we get 16 on your calculator. All right, let's try another one. We're going to press second x squared and then we're going to try 171. And I get a nice decimal. And let's go ahead and type in the next thing, -2, and then square root of 100. Just type it just like that in your calculator using those buttons above. I get -20. Now let's try the cube root. It's a little bit different here. We're going to have to get the cube root, meaning we want to get that that cube outside. It's different than the square root, so you have to go dig a little deeper for this. You have to click the math button. The math button is right underneath the alpha button, which is green. And then you're going to choose option number 4. If you choose option number 4, it's going to select the cube root. And at that point, you just have to pop in your number. So I'm going to pop in 343. When I do that, I get 7. Try that same sequence. Math, 4, and then 250. I get 6.29. And then try the last one. 4, math, choose option number 4, and then -27. So feel free to use the calculator from here on out. Okay, let's do one more problem, just applying everything that we've really done in this lesson and the one before. Because now we have some square roots and some cubes. So let's go ahead and work this. I see that I have a top and a bottom, so I'm going to actually go ahead and I'm going to put top over here and I'm going to put bottom way over here. All right, the top looks a little bit more intense. Oh, and by the way, don't forget about this little guy. He's kind of like I'm going to tack you on at the end. But let's go ahead and work with this guy. 6, I'm going to go ahead and put a -1 in for my a and square it. -2, and I'm going to multiply him by the square root of -1 in parentheses, right? Minus -5. That's going to be my top. Okay. Order of operations. Now I have exponents here, but I also have this square root. Sometimes I just like to consider square roots as part of grouping. So let's go ahead and do the square root first. I have -1 minus -5. Isn't that -1 or negative and a -5? Isn't that a plus? So really I have, I'm going to go ahead and just rewrite everything. And I have the square root of 4, which we know is 2. So really I have 6 times -1 squared minus 2 times 2. So I'm just going to go ahead and at this point my parentheses are done, so I'm going to work on my exponents now. -1 squared is 1, so 6 times 1 minus 2 times 2. Now I just have some multiplication to do. I'm going to do them together. So 6 times 1 is 6 minus 2 times 2 is 4. That's going to give me an answer of 2. All right, that's my top. Let's go do my bottom now. 2, absolute value of, remember, -2, and I have a cube. I'm going to do what's inside first. So -2 times -2 is 4. And then 4 times -2 is going to be -8. So I have 2 times the absolute value of -8, which I know is going to be 8, right? Which is going to give me 16. Okay, now I've got a top and a bottom. Let's go ahead and, you know what, we're going to call this little negative 4a. We're going to call it the side, just to keep ourselves organized. And I have a negative 4, a, which is negative 1. Well, that's nice and easy. That's just going to be 4. Okay, so putting it all together now, I'm going to put it all in this little space right here. Try to stay a little organized here. So I have my top, and I have my bottom. And I'm actually going to take that, and I'm going to subtract 4. Okay, so 2 divided by 16, well, I know that's going to be an improper fraction, which is going to simplify to 1/8. And then I'm going to subtract 4. So you're going to see how all this has been, all this is applying itself to the lessons that we've done previously. So I'm going to go ahead and divide this by 1, and I'm going to go ahead and make myself a common denominator. So when I multiply that 1 by 8, I also have to multiply the top by 8, which is going to give me 32. And when I subtract them, it's going to give me negative 31 over 8, which I cannot simplify, so that will be my final answer. All right, that is the end of the square root and cube root lesson. Let me know if you have any questions.